Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm over at Cliosoft with Prathna Sekar, who's going to talk today about network storage optimization for IP. So Prathna, we have a lot of data coming into these designs. You think about all the different IP blocks and all the different interactions between these various different things. There's a lot of data being moved around. What's the problem in terms of managing that?
Well, designs keep getting larger and larger, and in turn, so does the data footprint on the network storage. So this is because the layout and schematics and other such binary data can get quite large, and rightfully so. But larger the designs get, the more design files there are. It's going to put a strain on the network storage that you have. So that said, the more number of files and the sheer size of the files are not the only factors that strain your network storage.
So with all this data, you really want to be able to share this data too among your whole team, right?
Definitely. So collaboration is a big aspect of design data management and IP management.
So why don't you draw this out for us?
Sure.
So Pratna, you have a lot of design data coming in here. What do you do with it?
Right. So, say for example, you have a design project with a lot of analog design libraries. And for a simplistic example, let's say you have a project with 1 gigabyte of data in there. Now, as a user, you're trying to get all of this data and start developing more on it. You're trying to create more revisions, you're making changes onto the existing data. And so, first off, you're going to be creating a work area for yourself of the project. Now, in a typical or a traditional physical copies type of work area, you're looking at replicating or duplicating the entire 1 gigabyte of data onto your work area. Now, this is just one work area, but imagine all the people in your company trying to create work areas for this particular project, and you're going exponentially higher on that number, and this is basically increasing amounts of disk space usage on your network storage.
And this is the classic divide and conquer type of approach, right? Because now you have 1 gigabyte, but within this whole design, there may be terabytes of data.
That is true. So this can, if you have 10 work areas, you're going to get to 10 gigabytes in this particular project. And this is like a smaller size project if you think about analog design projects.
So what's the big problem here? Is it just the amount of data? Is it managing the data? Is it sharing the data?
It's actually a little bit of everything. So you are not only working on this data actively, you have to have a way of ensuring that your data is stable when you're trying to run long simulations in your environment. And there's going to be hundreds of other people trying to check in data, new versions. And so, but you still want to be on the stable version. So you can do that. And along with that, once you're done with your simulation and you're satisfied that the quality of your data is good and you're ready to check it in, now you can commit your changes to your system or your project, and other people in the work area will be able to simply update and get the latest version.
One of the problems with all this data is you have to store it somewhere too, right?
That's correct.
What do you have to do in order to optimize that so that you can actually get it quicker and also not basically bloat all your storage?
Right. So you can have a cache system. And so, for example, I'm just going to draw it out here. So this is your cache, and this is basically going to store all the cached data and metadata information. And now, for example, I was talking earlier about work areas, and so let's say you have a user work area. And we'll take an example of a schematic and call it schematic A. Now, you're probably using a version of the schematic in your work area for running your simulation or other purposes. So let's call that version, say for example, version 37. Now, From your work area, you could simply have symbolic link pointing to this real copy of the file inside the cache. Now, this is one version of one file in the project. You could have a lot of different, you could have really large analog design libraries with a lot of schematics and a lot of layouts, and that's a lot of binary data. Now, imagine if you were to replace all of that data with just symbolic links pointing to the actual data in the cache. You're talking about reducing the disk space consumption to about tens of megabytes.
So you talk about version 37. If somebody comes back with something else and they make a minor change, does that become version 38? And does this now start building up in your cache and your disk space?
That is absolutely right. So when somebody else checks in a new version, you go ahead and create version 38 in the cache, and it stays there for as long as there is somebody using that version. So let's say, for example, there is another work area owned by a different user, and this person is checking in version 38 of the same object. Now, you still want to be using version 37 in your work area, and you can do that by simply doing nothing at all. And once the time comes for you to update your work area to be using the latest version, you can simply update your work area and get that version.
Where do people run into problems with this? What are you seeing as the big challenge?
So the big challenge here is that your cache could keep getting bulkier and bulkier, where people are adding new versions of every single layout and schematic, and thereby it gets bigger.
So how many versions do some of these designs have? Is it hundreds, thousands?
There could be. We have seen in some semiconductor design companies, they go up to thousands of versions. And it's not just the data itself. We're also talking about all the metadata that goes around this data that's checked in. So metadata could be who is the author of this particular schematic A, that's a metadata. And things like what time was it checked in. So these are extra information that goes along with the data itself that also needs to be cached in the cache.
So what you're really trying to do here is to streamline how much data gets stored, how it gets used, and how many people can access it quickly.
That is correct.
So this is the classic problem that people have been running into with limited disk space forever. How do you get rid of some of that data? How do you make sure that you get rid of the right data?
Right. So as long as somebody is using the data, you want that data to be safe and secure in the cache. Of course, all the data that is ever checked in remains in the repository, but now you're talking about data being checked in by multiple users into the cache, and although we're saving space on the user work area side, we're actually making the cache bulkier. And to solve this problem, we have what you call a cache scrubber, which turns on automatically when it recognizes that the symbolic link count usage of on one particular version, if it goes below 0, then that means that nobody is using that version anymore. And so it would be okay to scrub it off of the cache, thereby saving you space.
Does it matter if this is done locally on premises versus in the cloud?
Not really, because the same mechanism would work on premises and on cloud.
How about things like security? Do they enter into the picture here as well?
Definitely. All the data that's in the repository and the cache and all the data transfer that's going on between the clients and the cache and the repository, they're all secure, they're all encrypted.
So what's changed here? Is this a completely new problem?
Not really. This problem has existed as long as people have been doing schematics and layouts in the industry, and we're talking about large amounts of binary data, and this data keeps growing in size as we're doing more and more complicated designs.
So really it's an effort to keep up with the more data that we're trying to work with here.
That is correct.
So let's take this into the real world. What have you actually seen out there?
So we can take one example, which is the Large Hadron Collider, if you're familiar with that project. There were a lot of research institutions, and there are still a lot of research institutions around the world that are collaborating on this project. And surely they need some kind of version control that not only just keeps track of version history, but does more complicated things like keeps track of the metadata, also keeping in mind saving disk space, and at the same time getting faster performance to get cutting edge technology out there.
No matter how much data you're storing, there's a cost associated with that. Has that gone down as a result of Moore's law, or is it still as expensive or more expensive than it was in the past as these chips get larger and more complicated?
Right, so we're not really talking about the kind of disk you could buy from Fry's here. So network storage is expensive, and you could have a system like this. You can keep all your data on premise, or you could put it on the cloud. Either way, you would be saving the amount of money you would spend on network storage by using an optimized solution like this.
Prathna Sekar, thanks for a great explanation.
Thank you, Ed.